Hi, welcome to another episode. So today I would like to give a quick recap on a topic on P4, especially that falls under chapter number 6. That's its category, a subcategory of integration. It's actually in a quick revision of a topic called integration by parts. What is that? Integration by parts. So another name of this is actually the reverse of chain rule. It is actually the reverse of differentiation using chain rule. Okay, let's see. Okay, as we know that what is a chain rule, right? So what is a chain rule in differentiation? Suppose you have a function of x, like we have two functions, let it be v and u. And what is the speciality of this u and v? This is a function of x, and this is another function of x, say f of x and g of x. These are two functions, u and v. And suppose if you are differentiating this function, okay, so suppose I have the product of these two functions. I would like to differentiate the product of u and v. So we are going to use what? We are going to use product rule, right? We are going to use product rule. So what is the product rule says? The derivative of first function, right? So that is what du over dx multiplied with the second function plus the first function into the derivative of the second function. Am I correct? So that is a scenario, right? Now, suppose, for example, I would like to make, u times dv by dx as my subject. So that means I would like to bring this to this side. So here what happens is, we can say that u times dv over dx, we can write it as d by dx of uv minus du over dx times v. So we are doing some simple algebra. Okay, so u times dv by dx is equal to d by dx of uv minus du by dx into v. Now what I'm trying to do is, I'm just integrating both sides. I'm integrating both sides. I'm integrating both sides with respect to dx. With respect to dx. So what happens? Integral of u times dv over dx times dx is equal to what? See, d by dx of uv dx means what happens? The derivative of, if you are integrating a derivative, what happens is we will get the mother function. So that means this dx and dx got cancelled. Integral of duv means integral of d times uv minus du over dx times v dx. Okay, so what happens is this becomes uv minus, I would like to write v first, du over dx. I'm just rearranging this. So integral of u times dv over dx times dx is actually what? This is a very important formula. U times v minus v integral of v times du over dx times dx. Okay. I will explain with the help of one example. I would like to explain this with the help of one example. So let's see one question. So I would like to take some questions from our textbook itself. So let's see one by one. So for example, a question from our textbook itself. Okay, I'm inserting here. So integral of x cos x dx. So how we are going to do this question? Integral of x cos x dx. So first of all, you identify which is our u and which is our dv over dx. Okay. So here, which one is u? The first stuff is our u. So u is what? X. What is dv over dx? dv over dx is cos x. So if dv over dx is cos x, then what we can say is, what is v? How you will get it? Cross multiply, right? So if you're making dv the subject, it becomes what? Cos x times dx. And if you're integrating both sides, v is equal to integral of cos x is simply sin x. Am I correct? So v, what is v? V is sin x. So therefore, integral of, what is our formula? We are going to recall that formula. U times dv over dx. Dx means what is that? It is uv minus integral of v times du by dx times dx. Correct? So here, what is our u? Integral of x cos x dx. How we can write it as x times, what is v? V is sin x, right? So x times sin x minus, what is v? V is sin x, correct? Sin x times, what is the derivative of is this thing, that is du over dx. So du over dx means it is simply 1. If you're differentiating x, it becomes 1, right? 1 dx. So it eventually becomes x sin x minus sin x times 1 is simply sin x dx. So what is integral of sin x? That is, integral of sin x is gonna be plus minus into minus, because sin x is minus cos x. So minus becomes plus cos x plus c. So the answer for this question is x cos x dx. Integral of x cos x dx is what? X sin x plus cos x plus c. So that is the idea about this question. Any confusions? So we'll do one more question similar to this, then we'll get a clear idea. Okay. So we'll do one question from our exercise itself. Let's do one question. Let it be seen. So this is another question. So here, which is our u? X is our u, and 6 square x is our what? dv over dx. So we will write here, what is u? U is x. Since dv over dx is 6 square x, dv is equal to what? 6 square x dx, correct? And if you're integrating this, what happens? Integral of 6 square x dx, right? Integral of 6 square x is going to be what? It is simply tan x. So then we are applying the same formula. Integral of x 6 square x dx would be, what is that? U, that is our x. And what is v? This is our v, correct? So v is what? Tan x minus integral of, what is the next step? Simply our v. V is what? Tan x times, what is the derivative of x? It is 1, right? Dx. Am I correct? So that is the idea about this. So x tan x minus tan x dx. Well. So what is this? This tan x, we can write it as sin x over cos x, right? Sin x over cos x. So now in the second part, we can apply the integration by substitution. So I would like to do the part 4, this thing, integral of sin x by cos x dx. So I would like to make a substitution. Let k as cos x. So what happens? What is the derivative of this? dk by dx is what? The derivative of cos x, that is minus sin x, right? Therefore, what is dk? dk is minus sine x dx. And if it is minus dk, what is that? It is sine x dx. So that means the derivative is present here. So here in place of sine x dx, we can replace it as minus dk. And what is cos x? Cos x is k, correct? And it eventually becomes what? Minus of dk by k. Am I correct? So what is integral 1 by k dk? That is natural log, right? It is what? Minus ln k, right? So here, what is our k? K is cos x, right? So it is minus ln cos x. So we can replace it as what? X tan x minus ln cos x plus c. So minus minus becomes plus, right? And what is the final answer for this? It is becomes x tan x plus ln, that means natural logarithm of cos x plus c. So that is the answer for this question. So x tan x plus ln cos x plus c. So that is the idea about this question. Now, sometimes you will get, a little bit complicated question. I mean, something out of the box. The question that is out of the box, like, some different scenario we have to apply, especially in, the integration by parts. Let's see one such question. Okay, so let's see one such question. Suppose, for example, the question's something like this, like the questions that's starting with e raised to x, e raised to x sin x, or integral of e raised to x cos x. Such kind of questions, how we are going to apply, the concept of integration by parts. This is third question, correct? So we will rewrite this question. Integral of e raised to x sin x dx, correct? Integral of e raised to x sin x dx. Then you might be wondering, so which one we will keep it as u and which one we will keep it as dv by dx? Okay, so u is what? U is e raised to x. So therefore, what is dv by dx? The next one is dv by dx, right? So what is our dv by dx? dv by dx is sin x. So what happens? dv is equal to what? It is simply sin x times dx. And if you're integrating this, what happens? Integral of sin x dx. So v is equal to integral of sin x is what? Integral of sin x is minus cos x, right? So we got it as v is our minus cos x. Then, so what is the formula for this? I would like to once again write that formula. Integral of u times dv over dx times dx means what? It is what? U times v minus integral of v times du over dx times dx, correct? So we are going to apply this. So integral of e raised to x sin x dx, we can write it as it is what? It is u times v, that is what? E raised to x multiplied with the minus cos x minus cos x times, what is the derivative of du? So what is du over dx? That is still e raised to x into e raised to x dx. Am I correct? So it becomes what? E minus e raised to x cos x, minus into minus becomes plus integral of cos x e raised to x dx. Cos x e raised to x dx. Again, the same thing, I mean, but with a different trigonometric expression appears here. See, here still that, it is not eliminated. Still two functions are there. So we have to integrate the product of two functions, correct? So then how we will again rectify or solve this part? So separately we will take this part, integral of cos x e raised to x dx, cos x e raised to x dx. So here we will simply change the order here also. What is that? We will write it as e raised to x cos x itself. E raised to x cos x dx. Okay, so here again we have to apply again the concept of the um, by parts. So what is our u? U is e raised to x. What is dv by dx in this part? That is cos x. Therefore, what is dv? Dv is cos x dx. And therefore, v is equal to what? It is sine x. If you're integrating, it becomes sine x. Similarly, what is du over dx? It's still e raised to x itself. So what is the formula? It becomes what? E raised to x multiplied by u times v, right? So what is v? V is simply sine x, correct? Sine x minus integral of what is our v? V is sine x, correct? And this is what again du by dx is what? E raised to x, okay, dx. So this part also we got in two terms. So this is actually the expansion of integral of e raised to x cos x. So what was our question? We need to evaluate what is integral of e raised to x sin x dx. Am I correct? And that we got it as minus e raised to x cos x plus integral of cos x e raised to x dx. But what is integral of cos x e raised to x dx? That is minus e raised to x cos x plus e raised to x sin x minus integral of sin x e raised to x dx. Okay. So here, what is this? Did you identify any speciality of this? This is actually what? This is actually the same question. This is what we need to evaluate, correct? Because the same thing is repeating after twice in applying these by parts, correct? So that means this is actually again, looping. I would say the term looping. That means after some time, the same thing is repeating. So what we can do is, we can simply call the integral of what? Integral of e raised to x sin x dx. Let that integral, we just call it as, let it be I. So that means this integral is actually I. So I is equal to minus e raised to x sin x plus, minus e raised to x cos x. My bad, sorry. So this is minus e raised to x cos x plus e raised to x sin x minus what? This is actually I itself, because the same thing, right? Now, if you are in bringing this minus I to this side, what happens? I plus I eventually, I plus I eventually becomes what? I plus I eventually becomes, I plus I becomes 2I, right? So this it becomes what? 2I. So that is equal to minus e raised to x cos x plus e raised to x sin x. So 2I is equal to, I would like to take, e raised to x common. And if I'm writing the positive term first, e raised to sin x minus cos x. Therefore, I is equal to what? E raised to x by 2 times sin x minus cos x. Therefore, what is I? Integral of e raised to x sin x dx. And what is our answer? The answer for this question is ex over 2 multiplied with sin x minus cos x. So that is the answer for this question. Okay. So any confusions regarding this part? Any confusions? That is e raised to x by 2 sin x minus cos. Oh, I missed that plus c. Always, since it is an indefinite integral, always we have to put a c after this or in the tail end. So e raised to x by 2 times sin x minus cos x plus c. So that is the idea about this question. And we will wind up the session by doing one more question. Okay. So I hope you got an idea about integration by parts, right? Okay. Let's see one more question. So this is a question from our exercise. Let's see. So here, one more question. So use integration by parts to find what is x cos 4x dx. X cos 4x dx. X cos 4x dx. Let's see. So integral x cos 4x dx. So what is our u? U is x, and what is my dv by dx? That is simply cos 4x. Correct? Therefore, what is b? If I'm integrating this, what happens? It becomes sine 4x over 4. Correct? So that is the idea. So that is a basic definition, right? So it becomes what? It becomes x times cos 4x. Oh, it's actually x sine 4x over 4 minus integral of what is v, the sine 4x over 4 times derivative of x is 1, because du over dx is actually 1, right, into dx. So it becomes what? It becomes nothing but 1 over 4 x sine 4x minus 1 over 4 is again common, integral of sine 4x dx. So it becomes what? 1 over 4 x sine 4x minus 1 over 4. What is the derivative of this thing? It's minus, right? So it eventually becomes positive. So 1 over 4 into 1 over 4 cos 4x plus c. So the final answer for this question is 1 over 4x sine 4x plus 1 over 16 cos 4x plus c. So that is the answer for A part. Now use your answer to part A to find what is integral of x square sine 4x. X square sine 4x. So here you can see that, see the the variation. So here if it is x, this becomes what? This becomes 1 over 4. So the question is, integral what is x per sine 4x dx, right? Let's try. So first you write this x per, and then what we will do is we will integrate this sine 4x. So integral of sine 4x is what? Minus 1 by 4 cos 4x, correct? Plus what happens? Plus what happens is we have to apply the second rule, right? So that means what? It becomes plus. It's not plus actually, because we are taking the integral, right? So it becomes minus 1 over 16 sine 4x. It's not over. Again, we have to differentiate it. The derivative of this is, the derivative of this part is 2x, because the derivative of x square is 2x. Then what happens? Again, we have to do the same process. What is that? Again, we have to write what? Or else we can straight away apply the formula. Okay. So don't, without a confusion, because in the B part they are asking what? Then I will compare this. Otherwise, you may get confused. So integral of x square sine 4x dx. That is our question, correct? So here our u is x square. Our dv by dx is sine 4x. So therefore, v is straight away we can write it is minus 1 by 4 cos 4x. Right? Now, du over dx would be 2x. So this becomes what? X square multiplied by minus 1 by 4 cos 4x, then minus integral of minus 1 by 4 cos 4x multiplied with the derivative of x square, that is 2x dx. So minus minus becomes positive. So it becomes minus x square over 4 cos 4x plus 1 by 4 integral of 2 by 4, because 2 also common, constant, right? So cos 4x times x dx. So again, we have to do the same process. See, what is our u? In this case, u is x, and what is v? dv by dx is cos 4x. So what happens is, again, we have to apply by parts. Minus x square by 4 cos 4x plus 2 over 4. Then we will put a bracket here. Then this becomes what? X times. So if dv by dx is cos 4x, then definitely v is what? It is sine 4x over 4. So sine 4x over 4. Then minus integral of this becomes sine 4x over 4, that is our v, times the derivative of x, that is d over dx is 1, right? 1 dx. So it eventually becomes minus x by 4 cos 4x plus 2 by 4 means it is 1 over 2 times x into sine 4x upon 4 minus 1 by 4 is common. Integral of sine 4x is actually minus 1 by 4 cos 4x. And eventually a plus c is there. So if you are rearranging this answer, it becomes what? Minus x square by 4 cos 4x, then plus 1 over 8 x sine 4x, minus into minus becomes plus 1 over 16 cos 4x plus c. So that is the answer for this question. So I hope you got it. I hope you enjoyed my lesson. And if you have any doubt in this by-part session, so please be free to drop a comment for this, and definitely I will reply you for your question very soon. So I'll be here with another video. Till then, bye-bye. Wish you very all the best for your exams. So some students are appearing for exam in the very near days. So prepare well, do your best, and I wish you can achieve very good marks in your A-level exams. Thank you. Thank you very much.